Hello, my name is Dr. Coca, and in this video, we're going to be completing the extraction experiment. So, in particular, we're going to be doing the drying part of the experiment. So, in this separatory funnel, we have our unknown in ether. We have already removed the impurity in the previous video. So now we just need to move on to the drying part. So for the first step in the drying part of the experiment is to add 2 milliliters of saturated sodium chloride. We also sometimes call it brine. So all it is a saturated solution of sodium chloride or table salt in water. So we add 2 milliliters of this to the separatory funnel. We place the stopper back on, grab it with our finger, shake it a few times, release the pressure in the hood, close the stopcock, and then we're going to put it vertically in the ring clamp. We're going to remove the stopper. After letting it sit for maybe a minute or so, we're going to remove the aqueous layer into test tube 5. If you were working with methylene chloride or dichloromethane instead of ether throughout this experiment, dichloromethane has a higher density than water, so it's actually the lower layer. So if you want the organic layer, you would have to remove that first, and then the top layer, which is the aqueous layer, would have to go into test tube 5. So since we're working with ether, we're going to remove the aqueous layer, which is at the bottom first. And as we get closer to the organic layer, we slow down. So all we have now in the separatory funnel is our ether layer containing the neutral unknown. Again, it already has the impurity removed. We're going to move now the organic layer into a 25 milliliter Erlenmeyer flask. Once it all has drained into that flask, we want to inspect it for any air bubbles. So as you can see, not air bubbles, excuse me, water droplets. So as you can see, pretty much everything is a once phase. So there's no water droplets inside of the ether. So if that was the case, that means we did a poor job of removing the aqueous layer. If you still have water droplets in there, you're going to need a lot of drying agent to be able to dry that organic layer. So instead of doing that, perhaps you could pour this back into the separatory funnel and try to do another extraction to just simply remove that little bit of water out into test tube 5 again, and then place the organic layer once again into this Erlenmeyer. But since it doesn't appear that we have any water remaining, at least to the naked eye, in our organic layer, we can add our drying agent. So in this experiment, we're going to be using sodium sulfate. And since we don't have much water left inside of our organic layer, we really only need a pinch of our sodium chloride, sodium sulfate. So about 100 milligrams, maybe 200 milligrams. We're going to pour that into our organic layer. So there is a solid, a white solid at the bottom of this Erlenmeyer. We're going to swirl this around. So the purpose of this drying agent is to remove any traces amounts of water that may still be trapped inside of the ether. So the experiment where we added brine to our ether layer removes most of the water, pulls it out of the ether layer. Because sodium chloride is so polar, it has ions and pulls that water right out of the ether layer. So that removes the bulk of the water. But by doing this step with the sodium sulfate or magnesium chloride is another common drying agent, that removes any trace amounts of water that we may not see with the naked eye that are still trapped in that organic layer. So we're gonna swirl this every once in a while, let it sit for about 5 minutes. At that point, there should not be any water left inside of our organic layer. So we can go ahead, and again, we're gonna skip ahead. We're gonna transfer this organic layer into a pre-weighed small beaker. So we take our transfer glass pipette and place it inside of the solution. And we try not to pick up any of the solids. So one trick for that is by placing the glass pipette directly pressed against the bottom of the Erlenmeyer. That allows very little of, if any, of the sodium sulfate to sneak into the glass pipette. So we're going to transfer that solution into the beaker. Do this a few more times, get all of the solvent out. And that leaves behind in this Erlenmeyer a small amount of sodium sulfate, or what we have added before. So we don't want that solid crystal that we can actually see. That's just sodium sulfate. It's not solid with ether. Our organic neutral unknown is going to be solid with ether the entire time. Is that yellowish color. And that when we transfer the ether, that's we're really transferring that organic neutral unknown. So we don't want the crystals that we could actually see. That's just sodium sulfate. Anytime you do any transfers in chemistry, you're always going to leave a little bit of product behind. For that reason, it's always a good idea to do rinses. So we want to take these crystals and rinse them one more time with ether. Okay, so you want to grab 2 milliliters of ether, pour it into here, and then transfer that over into this beaker. Then at that point, you're pretty much done with this part of the experiment. You just have to put that beaker into your locker, let the ether evaporate, and then after the next lab period, you'll have a solid. So the ether, when the ether evaporates, you'll leave behind your solid neutral unknown. At that point, it should be completely free of any solvents like ether. So you should be able to take your weight. That will allow you to determine the percent recovery from this experiment. You can also take the melting point. The melting point allows you to identify what the neutral unknown is, as well as how pure it is. So based on how close it is to the actual literature melting point. And that concludes the experiment.